Here are some notes for section 6.3. We're going to look more in depth at example 5. I encourage you to copy these notes down. These are going to be really helpful for you working through these problems. So if you need to pause the video at any time, I encourage you to do so. So let's take a look. Now we're looking at exponential functions of the form y equals a times b to the x minus h power plus k. So this form should look familiar because now we have an a and an h and a k, and we've seen those in vertex form for a quadratic function and for an absolute value function, and these values mean the same thing for an exponential function. Remember, our parent function is just y equals b to the x, so only the base and only the x. If our b is bigger than 1, remember that's exponential growth, and the graph is going to point up, moving from left to right, smaller numbers getting bigger very rapidly. If our b is between 0 and 1, that's an exponential decay function, still pointing up, but the numbers start very large and they get small very quickly. So from our parent function, our transformation happens when we start adding in the a, h, and k. Let's remember what the a value does. If our a value is negative, that causes a reflection over the x-axis. If our a value is bigger than 1, that's a vertical stretch by a factor of a. And if our a is between 0 and 1, that's a vertical shrink by a factor of a. Next, we have our h and our k values, which cause the translation, which slides the graph left, right, up, down. So our h tells us a horizontal translation, but remember, we have to be careful with this h value. Remember, it's after the minus sign. So the minus sign is really part of the formula that h comes after. Or you can imagine if you set this exponent equal to 0 and solved for h, x would equal h. Our k is the vertical translation, and that tells us if it's going to go up or down. So to graph our function, we're still going to make a t-table, but now we're going to put the h value in the middle. If you want, you still can put 0 in the middle, but because of the h, it's going to slide our graph, and I think having the h in the middle is the best way to have it. Then we're going to find our y values by plugging each of the x's in or getting it from our graphing calculator. We plot the points and draw the curve. We can also describe the domain and range. Our domain is always going to be all real numbers no matter what. You can also use this symbol for all real numbers, this double block R. And our range is going to depend. It's going to be an inequality describing the y's. And when we do this, the y values are going to change based on our k value in our equation. So make sure you look out for that k value. If our graph points up, the range is going to look like this. Y is greater than our k. But if our graph points down, then our range is going to look like this. Y is less than our k. So we're going to look at example 5. I'm getting this from the textbook here, so if you want to follow along, I'm going to go through this example and we're going to do it on paper. So I already wrote down the example. Here's our equation, y equals 4 times 2 to the x minus 3 power plus 2. Let's graph this function, and I'm going to make a t-table to make my graph. So let's make our x and y's, and I'm going to have 5 spaces here just like we normally do. And remember, we said we want to put our h value in the middle of our table. So our h value is the number being subtracted from the x up here in our exponent. Our h value is positive 3. Remember, it comes after the minus sign. So I'm going to put 3 in the middle of my table. I'm going to go 2 numbers down, 2 and 1, and 2 numbers up, 4 and 5. And now I'm going to find the y values. So I could do this one at a time and plug my x's into this equation and find out what it equals, or we can use our graphing calculator. I think it's faster to use the graphing calculator, so I'm going to go ahead and do that. Let's go to y equals, and let's type this equation into y equals. We have 4 times 2 to the power. Remember that get to the power, use the caret key over here by the clear button. And we want x minus 3 in the exponent. So since my calculator is an older calculator and the exponent is an expression, I have to put it in parentheses. If you have a newer calculator, then you just type it in, and to get out of the exponent, you hit the right arrow. And now we're gonna hit +2. So here's our function. Next up, we're gonna do second table, and let's get our y values. So I'm gonna start with 1. When my x is 1, my y is 3. Then when x is 2, y is 4, 6, 10, and 18. Okay, I'm ready to make my graph. I'm gonna go over to my piece of graph paper, and I'm gonna draw my coordinate plane on here. Now, since my x values are really mostly positive and my y values are gonna get very large very quickly, I'm gonna be strategic about how I make my graph. So I think for my y's, I'm gonna go by 2s. I think that makes the most sense here. And I'm gonna focus most of my attention on quadrant 1. And we'll go by 1s on the x-axis. So I'm just gonna label my axes here. So this is for my x, I'm going by 1s, 1, 2, 3, 4, 5. And for my y's, I'm gonna go by 2s. Let's make this 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, let's plot these points on the coordinate plane. So first I have 1, 3, then 2, 4, then 3, 6, then 4, 10. We can see that they're getting much bigger, much faster now. 5, 18. And there we have our points. Now we have to be very careful here about how we draw the end of our graph and thinking about where it's gonna get flat horizontally over here. We wanna think about the k value in our equation. So I'm gonna go back to my equation on my paper up here. My k value is the number being added at the end of our equation. So our k value is 2. That means that our graph here is gonna get closer and closer to 2. It's gonna approach 2, but it's never actually going to equal 2. So I'm gonna write myself a note here because the graph approaches 2. It's never gonna equal 2, but it'll approach it. So now when I go to graph this and I draw this left side, I'm gonna go right along the 2 line, just above it, and then start curving up and form this hockey stick, this nice curve here. But notice how on the left side, I didn't let my graph go below the 2 line. It's approaching 2, but it'll never equal 2. And there it is, there's our graph. And if I want to, I can go into my graphing calculator. Let's hit graph. And look at here, you see how it's almost flat here as it's getting close to 2 and then it jumps up. So our graph should definitely match what it looks like on our calculator. Finally, let's describe the domain and range of this function. So our domain is always going to be all real numbers. No matter what, for all of these functions, these exponential functions, it's all real numbers, or I can use that symbol, that double block R. Let's talk about the range of our function. Since I'm always talking about the y's, I'm gonna start with writing down y. Since our graph is pointing up, this is greater than. And now I want to look at the k value for this number. Remember what we said our graph is approaching? It's approaching 2, and that's because of this k value, the number being added at the end. So that's going to be our range, y is greater than 2. Okay, we're going to take a look at another example like this just so that we can get the hang of it. And I'm going to get this example from Monitoring Progress. Okay, we're gonna take a look down here at monitoring progress number 7. Let me write down the equation. It's y equals -2 times 3 to the x plus 2 power minus 1. Okay, our first step is we're going to graph the function and then we'll describe the domain and range. I'm gonna make my t-table with my x and y. with 5 spaces here. Okay, remember I need to decide what my h value is, and the h is going to go in the middle of my table. Now I have to be careful here because the h should have been after a minus sign. But in order for this h to have become plus 2, that means that our h is really a negative 2. Another thing that I can do here is if I set this exponent equal to 0 and I say x plus 2 equals 0. Imagine solving for x here. I would subtract 2 from both sides and I would get x equals negative 2. So again, this is why our h value is really negative. So it's always the opposite of what you see here. So just be careful with that h. And let's also say our k value while we're at it. Our k is this negative 1 being added at the end. And the k is always what you see. There's no trick with the k, only the h is the opposite. The k is what it is. Okay, I want to put the h in the middle of my table, so I'm going to put negative 2 here, and I'm going to go down 2 numbers, negative 3, negative 4, and up 2 numbers, negative 1 and 0. Let's get our y's from my graphing calculator. I'm going to go to y equals. Let's type this equation in. Negative 2 times 3 to the power of x plus 2, and then minus 1. Okay, again, if you have a newer calculator, your screen is going to look different than mine. I have an older calculator, so that's why I need to use the parentheses, so this whole thing is in the exponent. Just make sure your minus 1 is not in the exponent. Let's do second table, and I need to scroll up to see my numbers here. And here we go. I'm going to copy my numbers down. Let's round to the 10th place. So for negative 4, I have negative 1.2. For negative 3, I have negative 1.7. For negative 2, I have negative 3. And negative 1 is negative 7. And then 0 is negative 19. Okay, so I have my y values. I'm ready to make my graph. So I'm going to go over here to my graph paper. And again, I'm going to think about how I'm going to set up my graph. I'm going to focus mostly on quadrant 3, just because I have both negative x's and negative y's. Again, for my x's, I'm going to go by 1s. And I think for my y's, I'm going to go by 2s again. I think that makes sense. Okay, let's label our axes. This is negative 1, negative 2, negative 3, negative 4, negative 5. And let's do our y's. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, negative 20. Okay, let's plot our points on the coordinate plane and let's look at our graph. So we have negative 4, negative 1.2, so that's just about halfway here. Negative 3 and negative 1.7, so almost to negative 2. Negative 2, negative 3. Negative 1, negative 7, and you can see the numbers are changing a lot now. 0, negative 19. Okay, now before I connect these points, remember I need to think about where is it getting flat over here before I draw the end of the curve. So I'm going to go back to where I talked about the k value in our equation. Since our k value is negative 1, our graph is going to approach negative 1. So my negative 1 line is right here in between 0 and negative 2. I'm going to make it get flat right along negative 1 and then draw my curve from there. So just be careful how you're drawing this kind of tail, is what I call it, of your exponential function, and think about what it's approaching, because that's going to help you say what your range is and say it correctly. All right, so there's our graph. Our graph looks like this, and let's double check the graph in our calculator. I'm going to hit the graph button, and we can see it's right along the negative 1 line, and then it jumps down just like that. And I can't see down to negative 19 like in my graph, but we can see it does look very similar. Okay, our last step is let's talk about the domain and range. Our domain for this function, again, is all real numbers. It's always going to be all real numbers. Let's do our range for this function. I'm going to start with y. Look at how the graph is pointing down here. So since it's pointing down, it's less than. And now think about where is it approaching our y's here. It's getting flat at this -1 line, and then it's jumping down from there. So its y is less than -1. And again, the -1 comes from the k, which is the number at the end of the equation. I hope you found this helpful in doing these graphing exponential function questions.